G'day and welcome to a video explaining some trigonometric ratios for 5.2 mathematics in New South Wales. So trigonometry is what we're dealing with here, and in trigonometry, that word trigonometry really just means triangular measurement. So it's all about triangular measurement. Okay, now trigonometry dates way back, but we can use it pretty well today, and we can use it in a lot of different ways. Now, something that we do need to know a little bit about before we get started is that we use Greek letters in trigonometry a lot, and our Greek letters that we tend to use are theta, sometimes we use alpha, sometimes beta, and sometimes phi, if I draw the phi correctly. And then occasionally we also use gamma. Now, some of my Greek letter drawings may not be perfect, but get the gist. Now, what we have is we have our angle of theta. We use it to represent unknown angles, and we have that just in here in these little corners. These little dudes, these are what we call angles of reference. It's an angle of reference, and that's what we base all of our other information on. Now, we need to be able to identify sides of the triangle. We're always dealing with right-angled triangles in terms of these particular ratios and what we do at the beginning. So we have our two right-angled triangles here, and we have our right angle, and always opposite our right angle is our H for hypotenuse. Okay, so the hypotenuse is always opposite our right angle. Okay, so the hypotenuse is always opposite the right angle. Now, our other two sides, we have the opposite side and we have an adjacent side. Now, our opposite side, is always opposite the angle of reference. Okay, so the opposite side is opposite the angle of reference, directly opposite. And then we have our last side, which is the adjacent side. And that word adjacent, well, that just means next to. And it's always next to the angle of reference. And that's how that all works. Okay, so that's how we label all of our sides. Now, we use three general ratios at the beginning of trigonometry. So we use three main ratios, and our three ratios are the sine ratio. Okay, we have a sine ratio, we have a cosine ratio, and cosine really just means complements sine, so they fit really nicely together. And then we use a tangent ratio, which uses the other two in it. Now, we do use 3-letter abbreviations. And they get us sine, cos, and tan. So sine, cosine, tangent, or sine, cos, and tan. Now the sine ratio looks kind of like this. We use sin for sine, theta for our reference angle, and it is always the opposite side over the hypotenuse. That's how we find that ratio. We always use the opposite side and the hypotenuse for sine. Our next little ratio down is the cosine ratio. And this one is cos theta. And for this one, we actually have the complement of sine, so we actually need to use the adjacent side. And that's also over the hypotenuse. And then our very last ratio is the tangent ratio. So that is tan theta. Now tan theta doesn't actually use the hypotenuse at all. It uses the opposite side. And pops it over the adjacent side. And that's how our ratios sit. So that's how we find what values we need to pop into our ratios. Now I can give you a little bit of a memory aid. There is a mnemonic device. It is a series of letters. I think it sounds a little bit like the name of a volcano because it kind of rhymes with Mount Krakatoa, but I like to call it Mount Sokotoa. So it's name of a volcano, really. But it's Sokotoa, Sohchahtoa, and it just literally means sine, opposite, hypotenuse. Okay, then the next three letters we have cosine, adjacent, and then hypotenuse again. Okay, and then the last ratio there is our tangent. And then we have our opposite and the adjacent. So that is our little memory aid. Hopefully that gives you a little bit of an idea of what's going on and will help you. Advice would be to, whenever you're doing trigonometric questions or trigonometry questions, pop this device somewhere on a page so that you've got it to refer to. Let's have a quick look at some examples. Okay, we have a couple of examples here. All we need to do is label the three sides on this triangle. So here is our theta. That is our angle of reference. Okay, that's our angle of reference, so we need to label everything according to that angle. Now we can see there that the hypotenuse is pretty easy to spot, as it is directly opposite the right angle. Okay, directly opposite our right angle there. And now we can chuck in opposite and adjacent. We were supposed to do the hypotenuse last, but it was easiest, so let's do it first. Now our opposite side is opposite our angle of reference, so that's this one over here. And then our adjacent side is the one next to our angle of reference. So that's that one there. Okay, so what we're going to do is we're going to find a trig ratio for each of these triangles. So the first thing we want to do is we want to label our sides. We have H, O, and A, the initials of our three different side names. So because we have the H and because we have the A, we go back to our SOHCAHTOA word because it's the A and the H, the car, so that means it's cosine. So we want to use cos theta equals A over H, and then we put in what we know. We don't know the value of theta yet, but all we're going to do is pop in 5 over 7. That's all we need to do for this type of question. Our next one, we're going to do the same thing, label our sides, H, O, and A. For this one, we don't have a value for the hypotenuse, so we can't use the SOH or the car because those both have the hypotenuse in them. So we're left with tan, or the TOA. So we want tan theta equals opposite over adjacent, or tan theta, which is 3 over 5 for this problem. That's it. That's the basics of those trig ratios. Good luck with those questions. See you in the next video.